Robert Gagne was a pioneering educational psychologist whose work transformed how we understand learning. His concept of levels of learning provides a structured framework for educators and students alike. Gagne's hierarchy shows that learning is not a single, uniform process, but a progression from simple to complex skills. This approach helps teachers design effective curricula and empowers students to better grasp their own learning journeys. In this video, we'll explore the theoretical foundations of Gagne's model, break down each level with practical examples, and discuss how these insights can be applied in real-world educational settings. Let's begin by understanding the core principles behind Gagne's influential theory. Gagne's theory blends behaviorism and cognitive psychology, focusing on both observable actions and internal mental processes. He believed learning outcomes could be categorized, and each category requires specific instructional conditions. Two key principles underpin his model: hierarchical learning, where each level builds on the previous one, and the idea that different types of learning need different instructional strategies. For example, before solving complex problems, learners must first recognize stimuli, form associations, and apply basic rules. This hierarchy ensures foundational skills support higher-level thinking. Understanding these principles is crucial for educators aiming to sequence content effectively and for students seeking to master each stage of learning. Signal learning is the most basic form of learning, closely related to classical conditioning. It involves developing a generalized emotional or reflexive response to a signal or stimulus, often unconsciously. For instance, a student may feel anxious when hearing a test bell because it's associated with exams, or a classroom bell signals it's time to stop talking. Educators can use consistent signals to manage classroom behavior, while students can use cues to trigger productive habits. Establishing routines where specific cues prompt expected responses lays the foundation for more advanced learning. This level is essential for creating a structured learning environment. Stimulus-response learning involves forming a direct connection between a stimulus and a specific action, similar to operant conditioning. Learners respond to a stimulus with a particular action and learn through reinforcement, such as rewards or feedback. Examples include a student raising their hand to speak or pressing the correct key in a typing lesson. Educators can provide immediate feedback and use drills to reinforce correct responses, while students benefit from repeated practice until actions become automatic. This level is crucial for building habits and reinforcing foundational skills, making learning more efficient and effective. Chaining takes learning a step further by linking multiple stimulus-response connections into a sequence of actions. This can be done through forward chaining, where steps are learned in order, or backward chaining, starting from the final step. Examples include solving a mathematical equation step by step, or writing a structured paragraph with an introduction, body, and conclusion. Educators can break tasks into smaller steps and teach procedures sequentially, while students can use checklists to remember sequences and practice multi-step processes. Chaining is vital for mastering complex tasks and ensuring each step is understood before moving on. Verbal association focuses on connecting words and meanings, building on chaining but emphasizing language. Learners link words, symbols, or phrases, developing vocabulary and communication skills. Examples include learning the multiplication table or memorizing definitions in a science class. Educators can use repetition and verbal rehearsal, encouraging students to explain concepts in their own words. Students benefit from mnemonic devices and active recall techniques like self-quizzing. This level is essential for language development and helps learners move from rote memorization to meaningful understanding of terms and concepts. Discrimination learning involves the ability to distinguish between similar stimuli and respond appropriately. Learners identify differences and avoid confusion between similar concepts, such as distinguishing between there, and there, or recognizing different mathematical symbols. Educators can provide contrasting examples and use comparison activities, while students focus on subtle differences and practice sorting or categorizing information. This level is important for developing precision in understanding and responding to nuanced information, which is critical for academic success and clear communication. Concept learning involves understanding categories, principles, or abstract ideas, moving beyond memorization to true comprehension. Learners group objects or ideas based on shared characteristics, such as recognizing that different animals are mammals or understanding the concept of democracy. Rule learning builds on this by combining concepts to form rules and applying them in various contexts, like using grammar rules or mathematical formulas. Educators can use examples and encourage students to identify defining features, while students create concept maps and practice applying rules to new situations. These levels foster deeper understanding and flexible thinking. Problem solving is the highest level in Gagne's hierarchy, requiring learners to apply rules and concepts to new and unfamiliar situations. This involves critical and creative thinking, analyzing problems, developing strategies, and evaluating outcomes. Examples include designing a science experiment or solving real-world problems like budgeting. Educators can use inquiry-based learning and promote open-ended questions, while students practice tackling unfamiliar problems and collaborate with peers. Integrating all levels, such as in teaching fractions, shows how learning builds progressively from recognizing symbols to applying knowledge in real-world scenarios. This holistic approach leads to meaningful and lasting learning outcomes. Gagne's levels of learning offer educators a clear structure for designing instruction, emphasizing the importance of sequencing content from simple to complex. Differentiation is key, as not all students progress at the same pace, and assessment should align with learning levels. Timely feedback reinforces correct learning and guides improvement. Students' awareness of learning stages helps them focus on mastering each level, adopt effective study strategies, and self-regulate their progress. While Gagne's model has strengths, such as clarity and practicality, it's important to remember learning isn't always strictly linear. By applying this hierarchy, both educators and students can achieve deeper understanding and real-world success.